Good morning, everyone. Myself, Yash Vyas. I am a student of International Institute of Professional Studies, DAVP. Today, I am here to present the assignment number 3 solution assigned by the Professor Dr. Saligram Prajapati sir. The first question is, find the root of equation x square minus x minus 1 is equal to 0. And the approximate answer of this uh, approximate root of this will be 1.61834. Now we will solve the following equation using the numerical methods like first bisection method. In the bisection method, we will follow this algorithm where we will first check the a into b, f of a into b, and if it is greater than 0 then error, else we will calculate the value of c, which is a plus b divided by 2, and then if modulus f of c is less than the tolerance, where the tolerance can be any number which is greater than 0 but almost approximately equal to 0, like 0.0001, and then if it is tolerance is less than, then return the value of c, which means the value of x is equals to c. And if not, the f of modulus of f of c is not less than equal to the tolerance, then the value of a dot f of c is less than 0. That means the b is equals to c, else the a is equals to c. And then I'll repeat this process until the tolerance is greater than the modulus of f of c. And then in the following question, we are taking a and b as 1 and 2, and then we can see the value of c comes out to be 1 plus 2 divided by 2, which is 1.5. Then we calculate the value of f of c, and then we check the f of c into then, and we understand that the f of a into f of c is greater than 0. Hence we will replace the value of c with a and continue this process until our tolerance, which is 0.001, comes. The final result from this method will come after almost 20 iterations, and if we have tolerance is equals to 0.000388 zeros and 1, and but if we take 0.001, then the result of this equation will come after 14 steps. Here is the code of the following, which we can use in our to generate the following, and the geometrical interpretation of this code is also given here. As you can see, the C comes to between the A and B interval, and hence the method is only successful only and only when the uh, value of the roots lies between the interval which is chosen by us initially. Now, the second method is the Regular-Falsi method. In this method, we will using the formula where the complete process is almost similar to the bisection method. Only the formula is changed for the C, where now the C is equals to a minus f of a dot b minus a divided by f of b minus f of a. Now we will do the following steps again, and then after the we have shown in this table the iteration, the value of c, and the value f of c, and in this equation the answer will come out to be 0.601770, and the time complexity for the Lagrange method is big O of n, and the space complexity is big O of 1. Now the secant method. In this method we use two previous iteration and no bracket needed. In this method the formula is this, and in this method the value of c, or you can say the new x, is always equals to the previous x value. We only use one value in the secant method, and in this method the approximate answer would be come out to be 1.61833. and the convergence in this method will come after 6 iteration. And you can say this method is not reliable, as in this method the answer may come and may not come in some cases, while the bisection and regular falsy method are most reliable method where the chances of getting the correct answer are higher than the secant and the other methods. Now the Newton-Raphson method. In this method, we will be using a formula in which the x n plus 1 is equals to xn minus f of xn divided by f dash xn. In this method, we will be assuming all the assumptions which we have taken in the previous video, part 1, uh, assignment number 1, and for all the coming up the questions, the assumptions which we will be taking are from the assignment number 1 assumptions, and here only the uh, solution of the question is being showed. So since we have this formula, in this method we mainly do one thing, that uh, whenever we get the uh, interval, for example, this is our interval, we only need one value and we use tangent in this, we don't use any interval in this method. So the value we are choosing is 1.10000. So firstly we will find the f of that x value, that come out to be negative 0.25, and then we will find the f dash x of that uh, value, which comes out to be 2, and after that we will calculate the new value, that is x n plus 1 value. After calculating that value, we will firstly see what is the uh, firstly see the difference between this value. If the difference between the xn and x plus n plus 1 is more than the tolerance, then the difference of their modulus is more than the tolerance, then we will move on to the next iteration, and the value of xn it becomes the value of xn plus 1, and we will continue it until the difference of xn and xn plus 1 modulus becomes the less than the tolerance, where the tolerance is 0.0001, and in this case we will achieve the result after 4 to 5 steps, which and this steps is, and this method is very fast and reliable, but not much reliable than bisection, but reliable than the secant, since it use only one point. So we try to guess the point near the roots only. Fixed point iteration method. In this method, we have the following equation: x square minus x minus 1 is equals to 0. And now we will find the value from a new function g, where we can say that x is equals to g, and we get the g using some replacement in the original f of x. After getting the g, we will find the value of g of x, and the initial point we have to guess by ourselves. In this case, we are taking 1.5.000, and then after finding the g, we and another thing, while finding the g, which we have to take in mind, that g dax x modulus should be less than 1 for the convergence, and if g dash x modulus is not greater than less than 0, then the convergence may not occur. And in this, since we have the new formula of g, that is 1 plus 1 by x, when we just have to iterate it until the error, which is the uh, g of x, x of n plus 1 minus x of n modulus becomes less than the tolerance, which is 0.0001. And in this case, we will achieve the tolerance after the 8 iterations. So, and due to this method, there are several disadvantages, like we have to assume the values and the function, and also make sure the function which are g of x, which are we are assuming also, that condition has to satisfy the condition. of less than 1. The time complexity and space time complexity for this is big O of n. The space complexity is big O of 1, and the rate of convergence is 0.382. The solution from this result comes out to be 1.61798878. Now question number 2. In this question we are given a following points, and the estimated we have to find the estimate f of 9 using the interpolation methods. The first method is Lagrange's interpolation. In this method, we have the given formula where p of x is equals to summation of yi xi lix, where lix is equals to uh, pi, and the pi in this we have to make sure that j is not equal to I, and x minus j divided by I minus j. In Lagrange's interpolation, we just have to apply this formula for the p of x, where the x is the value which we have to find, and then we will get the answer. In this, we have to find the L of 0 to the L of 4, the all the values points which we have given. For example, in this case, we have given 5 points. X is equals to uh, 2, 4, minus 2, minus 4, minus 8, and so we have to find the output for the following points, and then we have to put the following points in this formula, which here, and then after putting it we will get these values like 0.1115, 0.5338, 0.8889, minus 3333, 0.33, and 0.0222. And after doing the summation of all these value, we will get the value of f of 9, which is approximate 843. The space complexity and time complexity for the Lagrange's interpolation is space complexity is big O of n square and time complexity is big O of n. Now the Hermite method. In this method, matches the function values and derivative at the data points using the interval, for example 7, 11, and x1 is equals to 7 and x2 is equals to 11. Y1 is equals to 392 and y2 is equals to 14252, and the m is equals to 2.17217, and m2 is equals to 329. The Hamilton basic function t is equals to 0.5, where the x h is equals to x minus 2 is equals to 4, and t is equals to 9 minus 7 divided by 4, that is equals to 5. Then x, we will be finding the value of h0050, h1050, h01, and h11, and the respective values for this are 0.51, 0.215, and this, and after that we will do the apply the formula for p9, and from this we will be getting the answer as 8.66, which is approximately which is the approximate answer on the interval 7, 11. The time complexity and space complexity for this method is n square, big O of n square. And in this, the table which is given below is used to uh, derive the estimated central difference. Now the third method is Newton division method. In this method, we use Newton division table, which is given here, where we will be applying the formula for Newton division to get the values of this, where the formula is f of x plus 1 minus f of x divided by f of x minus x plus 1 minus x, and after applying the formula we will be getting the value of this table after each step. For example, in this, the first, x is equal to 5 and x is equal to 7, the f of x values are 150 and 394. So to find the value of that, the next step we have to firstly minus the 392 by 150, 392 minus 150, then divide 7 minus 2. So the value which come out is 1.121, and then we will go complete this table and doing with the all the others for the first column, then for the f first difference column, then for the third difference, and for the fourth and the last when we get this value is 0. After doing that, we will put the value in the formula which is given here, where will we be taking the first filled column, first filled row of each column. For example, in this case we will be taking 150, 121, 24 and 1, and the final one is 0, and then apply the formula where we will be minusing all the values of x minus all the uh, n minus 1 value of x and multiply it. In this method, from this method, the answer which we will get is p of 9 is equals to 8, 10, and the time complexity, space complexity for this method is a big O of n square. The fourth method is Newton forward. Fourth and fifth method, Newton forward and Newton backward, and Newton difference formula. These methods are not used for the non-uniform distances between the value of x, so we can't apply this formula. So there is no, we can't find the value of interpolation using this formula. But if in this data there were equal uh, distance point in the value of x, then we may can have used it, but currently we can't use that. Now the third question, numerical differentiation. Here the data for this question is given here, 5 comma 150, 7 comma 390, and so on. Now the first method which we will be using for this is in interpolation based method in the finite difference method. So the differentiative of Newton divide and difference interpolation at the value of x is equals to 9. In this, we will firstly creating the forward difference table or the backward difference table. Since in our data 9 comes uh, in the starting point, so we will be using the forward difference table, and so we will create the table as using the formula which is given here, the f of x, the forward difference is equals to f x plus h minus f of x divided by h. And after creating the table, we will use the value of the first row of each column, then put the values in the formula, and after that we will get the value of f of 9, which is approximately 261. And for the same, we will apply on the every point like 7, so we will be getting 2.17. For the f of 11, we will getting 3290, and for f of 13 we will be getting 6215. The time complexity for the following method is big O of n, and space complexity is big O of 1. In this, the central difference method may be used if the value of 9 may lie between the data set, and if value lies in the end of the data set, we may use the backward interpolation method. Now the fourth question is numerical quadrature. Here we will be using Newton-Cotes rule like triangles, sequence 1 by 8, sequence 3 by 8, and Weddell's rule. First, we will be using Newton-Cotes formula general derivation, the approximate for the integration of f dx by the integrating the interpolation polynomial through the equally space monodes. Dr is the integration of f of dx from interval a to b equals to h dot summation of wi dot f dot x1 where the xi is equals to summation of 0 to n li t dt, which is comes from the Newton-Cotes method. And then after putting the value of n is equals to 1, we will get the trapezoidal formula, which comes out to be h by 2 and plus h0 plus h1. And for this, on putting the value of n is equals to 1, we will get this sequence formula 1 by 3, where it is h divided by 2 into h of uh, 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 y0 plus yn plus 4 into summation of y odd and plus 2 into summation of y even. In this method, the error which may comes in Newton's 1 by 3 is minus b minus bracket minus a into h cube divided by 180. And for the formula for trapezoidal rule is h by 2 into f of a plus 2 f of summation xi plus f of b. For this Stephens 3 by 8, we have to put the value of n is equals to 3, and the formula of this is 3h by 8 divided by a into y0 plus y n plus the summation of y all the y except the y which are multiples of 3, and then uh, that into 4, and then the summation of 3y into 3. In this method, we try to take the number of values which are multiple of 3. In Stephen, we try to take the method which are multiple of 1. Uh, in this Stephen 3 by 8, we try to take the data in which data number of data is multiple of 3. In the Weddle method, we use n is equals to 6, and in this the data which we use is number of data which we use is multiple of 6. Now here is the formula for the Stephen 8 by 3, where formula is equals to 3h divided by 8 into f of x plus 3x1 plus 3x0 plus 3x3 f of x3. For the Weddle method, the formula is 3h by 10 into f of 0 plus 5 into f of 1 x1 plus f of x2 plus 6 into f of x3 plus 4 f of x4 plus 5 f of x5 plus f of x6. Here is the code for the different methods like this Stephens 3 by 8 and the Weddle method, and exactly 7 points are needed and for this method Weddle. And here the condition is method that n must be the multiple of 3. Now the fifth question. In this question, we have to solve the system of simultaneous equation. The simultaneous equations are, and their solutions that will be is 1, 2, 3 respectively. The first method which we will be using is Gaussian elimination with partial pivoting. In this method, we have to create a we have to take the use of matrix, and then we have to create a pivot which is normally the diagonal of that matrix, and we have to eliminate all the numbers which are below the diagonal or the pivot. In this, we use the forwarding method to eliminate the elements which are below the pivot elements. The pivot elements can be identified by as the I and j of the pivot elements are always same. So we have to find the elements which are below the pivot elements. In this method, we use the upper triangle to identify, and after getting the upper triangle, we have to use the back substitution method to get the value of x plus y plus z, as the lowest row of the matrix is only have the one element, so we can uh, directly substitute the value, and then we have to remember store that value and then use that value in the above row, and then we have to subtract that stored value and then divide by the current coefficient of other uh, the other element of that row, and through this method we can find the solution of the system of simultaneous equation in a big O of n complexity. The answer find from this method is accurate, that is x is equals to 1, y is equals to 2, and z is equals to 3. And the space complexity for the following method, where the is big O of n for the forward big O of n square. Now the second method is iterative method, which are Jacobi's and Gaussian sliders. The prerequisites for these are diagonal dominance check. Row 3 and 1 are not strictly dominant. Reordered, put row with a large coefficient first. In Jacobi's method, we use the iteration, and like that iteration, we firstly find the value of x, y, z using the equation, and then we initialize the value of x, y, z using any of the thing. Mainly we use this x, y, z is equals to 0, and then we iterate the value for the x, y, z, which comes out to in the next method, in the next step, and we do it until the error or the tolerance is until the answer is less than the error or the tolerance. In this method, in the Gaussian slider, we update each unknown immediately using the latest value. For example, from the first equation of x, you get the new x1 value. So in the second y1 equation, you will be using the x1 value, and then the z1 equation, you will be using the value of x1 and y1, and then in x2 you will using the x1 y z1, and y1 you will be using the x2 value, y2 value. In y2 you will be using x2 value, and in the z2 you will be using x2 and y2 value, and so on. So using the Gaussian slider iteration, we just reduce the number of iteration by 2 and make the iteration method 2x faster. The time complexity for both of the method is big O of n square, and the convergence condition is diagonal dominance. Now the sixth question is approximation theory. In this, we will be using least square and polynomial approximation methods. First, the least square linear approximation. The minimize s is equals to summation of yi minus pxi square whole square into p, and px is equals to a plus bx. The data points are the following: normal equation x n x I bracket close a, and these are the our matrix equation, and after substituting the value we will getting this following 535 53 and bracket a bracket 9 5 is equals to bracket 9526, and so on. After computing the values of computed sums, the value of n is equals to 5, the value of summation xi is equals to 53, the value of xi square is equals to 653, and value of summation yi is equals to 9562, and the value of summation of xi yi is equals to 1368653, and we will putting this value in the normal equation, and after putting that we get the thing. And after solving the normal equation, we will get the value of a is equals to minus 2423 and the value of b is equals to 404. The time complexity for this equation is big O of n m in plus m cube, and the space complexity is big O of n plus m. The linear fit we find from this method is y is equals to minus 2423 plus 409x. At x is equals to 9, the y is equals to minus, as the y is equals to approximate minus 2423, y is equals to approximate 1258. Now the second method, orthogonal polynomial approximation. Avoid ill conditioning for a normal equation. Such coefficient computing independent while inter product. Lagrange polynomial on internal interval -1 to 1, where the value of p E1 is equals P0 is equals to 1, P1 is equals to x, P2x is equals to 3x square minus 1 divided by 2, P3x is equals to 5x cube minus 3x divided by 2, and the recursion is equals to this equation which you can see here, and the coefficient Ck is equals to this independently. Then the Gauss polynomial on the interval -1 to 1, we will getting the value of x0, tx0 is equals to 1, tx t1x is equals to x, t x n plus 1 x is equals to 2x tnx minus tn minus 1 x. The minimax property of minimalize and maximalize error among all the degree n polynomial x f of x is equals to 1 by under root 1 minus x square map data 5 comma 7 to 1 minus 1 comma 1 before fitting. And here is the code for the following, and after that we proceed to the question number 7, where we have to solve the ordinal differential equation dy by dx is equals to x plus 1, where the x y0 is equals to 1, and the exact fit for this will be 2x to 2 e power x minus 1. Now the first method which we will be using is Euler's method, where the h is equals to 2. The function for the Euler's method is yn plus 1 is equals to yn plus h dot f of n xn comma yn. Here firstly we will place all the values of x for the h is equals to 0.2. So from starting from 0 to 1 there will be 6 values. After putting that, we will find the value of yn using the formula of y, using the formula of yn is equals to xn plus yn. After putting that, we will find the f of xn comma yn. After finding the value of xn plus yn, we will find the value of yn plus 1, then the y exact, and then we will try to find the error. After finding all the things, we will after finding this, we will continue for after doing this for the xn is equals to 0 0 and yn is equals y1 is equals y0 is equals to 1. We will continue it for the second y x0 x1 and y1 until we reach to the x5, that is equals to 1, and after using the formula we will get the value of y 5. In this method, the time complexity will be big O of n, where n is equals to xn minus x0 divided by h. As you can see, there are 6 iterations needed, and we can find them using the 1 minus 0 divided by the h, that is 0.2, that's come out to be 6. The space complexity in this method is 1. The final answer which we will be getting from this method is 2.9766. Now the second method is Rangi Kutta or method, or you can say it compute four slope estimate per step and bend them. The global error for this method may come out to be big O of n power 4. Here we have given the formulas for K1, K2, K3 and K4, which we have to use for the each value of x and yn. After doing that, we will put in the final value to get the value of the current yn plus to get the value of next yn plus 1, where that is yn plus k1 plus 2k2 plus 3k3 plus k4 divided by 6. And here the number of iterations are just like the Euler's method. We have to minus the interval b minus a divided by the h. The time complexity for the following is big O of n, and this method you can say it is a more accurate and most easy method to perform. In this, for the value of x0 and y0, you will put in the all the formula for k1, k2, k3, k4. After putting that, you will find the value of y1 using that formula of yn plus 1, and then you will do the same using the y1 and x1 formula to get the value of x2, and continue it till you get the value of y5. That is the final answer, which is 3.436563 in this method. Now the third method is pickle method or successive approximation. In this method, convert the IVP to integral equation and iterate y n plus 1 x is equals to y naught plus integration of 0 to x f of t comma y n t dt. In this method, we will be using this formula until for the all the number of iterations. In this, the limit is 0 and 1, so we will be using starting from the x is equals to 0. We will first put the value in the formula for y1 and get the value of y1 from this. The function y1 is equals to 1 plus x square divided by 2 plus 1 plus x. After getting the function y1, we will getting the function y2, and which comes out to be this x plus x 1 plus x square plus x cube by 6. After that, we will use the y2 to get the value of y3, which comes out to be this, and then we will use the value of y3. Mainly we have given the how many steps of y1, y2, y3 we have to use. If it is given approximation till the nth term, then we have to use till y2, but if approximate to the fourth, then we have to use y3. After getting the value of y3, we will put the value of x 0.2 to the y3 to get the exact answer. That's come out to be 1.242806, which is close enough. And the time complexity for the following is big O of n square, and the stage complexity is n square. Here it is given a short Python code for the implementation of this. Now the last method and the last question part of for the today is the Taylor series. In this method, the order is equals to 3, and we use the formula yn is equals to yn plus 1 is equals to yn plus h dot y dash n plus h square by 2 factorial dot y double differentiation n, and go so on. In this method, we have given we uh, have to take until the givens. If you assume it to be take the degree to higher, we mainly ignore the higher order y values in this method. We only take 3 y triple dash, and after doing that, we take the interval, and for interval 0 to 8, and then we will be finding the value using the following method by putting the value of y, yn, and then summation of this is the exact value of the next y, and we will continue it till we get the final answer, which is come out to be 2.56 and so on. In this method, the time complexity is big O of n plus n dot p, where n is equal to number of step and p is equal to order, and the space complexity is equal to big O of 1. Thank you everyone for listening to my presentation.